Alrighty, welcome back to CS 107. This week's focus is a game app. It's called Mario's Mushroom Chase. We will review the concept of procedures. I'm going to give you an overview of the thunkable coordinate grid. It's different than your sort of typical Cartesian coordinate grid, and we'll cover all the elements of Mario's Mushroom Chase. Corny joke of the week: what do you call a mermaid on a roof? That's right, Ariel. As usual, office hours. Got my hours about 5 to 7. Monday and Wednesday, you can catch the Section 1, Section 2 TAs. Good use of Piazza this last week. Appreciate it. It's good for questions about the course. And people obviously post anonymously. You should feel comfortable asking any type of questions. This is essentially an intro class, so definitely got to be able to ask those questions. I was hoping we would have the Thunkable Pro accounts this week. I will be transparent. There's a slight holdup because of where the school is at with COVID. Any financial transaction has to go before a finance committee. So the short of it is we got to wait. Hopefully the Thunkable Pro accounts come this upcoming week, but we're in process, and it's because the payment's taking a little longer than it should. So apologies for that. Reviewing this concept of procedures, it's one of the biggest concepts that we will cover. It's a piece of code that you can easily call over and over again. It's also known as a function. You come across procedures all the time in real life. Instead of telling someone going through all 12 steps that might be involved with brushing your teeth, you just say brush your teeth. So that's the idea of you have this procedure. It covers a list of commands, and instead of having to call each command every time one by one, you can just call the procedure. You're going to hear the programs we're using. They will use the terms functions and procedures synonymously. So you may hear function, you may hear procedure. They essentially mean the same thing. At higher levels of computer science, there is a difference, but for our purposes, functions and procedures are the same thing. Example that we used last week, you can imagine here's 3 events: screen 1 opening, a timer firing, and a sprite being touched, and they all basically have the same code. So instead of writing the same code over and over, what we can do is write the code once, turn it into a procedure, and then all we have to do is call the procedure. It's a lot simpler, and it's probably the most important fundamental concept in computer science. Another example here from something you're going to build today, where you'll have Mario colliding with a mushroom, or Mario colliding with a villain sprite, and you're going to want to set some of these sprites locations to a random location. And instead of writing that over and over again, you can just create a procedure called move random. Yeah, that's what it looks like. So last week for homework, you worked on a program called Lightbot, and in Lightbot you did level 2, which focused on procedures. So you again had experience where if you notice this coding area that's encircled in the red box, you have 3 move forward commands followed by, I guess, a light bulb and a turn command, and you need to do this 3 times. So instead of so it's 5 lines of code. So instead of writing basically 15 lines of code, all you have to do is write these 5 lines of code and then call it 3 times. So it's an example of how procedures, functions are used to make your coding much more efficient. This week you'll do another level of code lesson in code.org. It's focused on procedures. It's a little complicated at first, so I'm going to make a separate video that I'll post by the homework. So I'll show you how to do the first couple, and you should be able to run with it. It focuses on procedures. Let's get into the thunkable coordinate system. You're probably familiar, you probably remember back in the algebra days when you worked on the Cartesian grid where the origin was 0, 0, and it was in the middle, and you had quadrants. In Thunkable, it's a bit different. So actually the origin 0, 0 is all the way in the upper left, and in this particular screen that we'll be working on, you can consider the far right corner to be, the upper right corner to be 300, x and y is 0. You can consider the bottom right corner to be 300, x and 360, 0, and so on. And the reason why they do that is because programmers have to consider that a phone may not be, the screen is not like a uniform size. So if you're essentially trying to plug in coordinates, you always have to have a place and a number that's going to be consistent on any phone, whether you're on an iPhone or an Android or a Google phone. And so especially when mobile devices got big, this coordinate, or rather this way of looking at the coordinate on a screen became more sort of institutionalized, where 0, 0, the origin is set up in the upper left. So there's a little background for you. A concept that I wish that I had covered, rather I realize now that I should have covered a little more thoroughly, had to do with 2 weeks ago you built the countdown timer and it used this timer component. And so the main event, the reason why the timer component is important is because there's this event where it fires, and you can determine how often it fires. The default is 1,000 milliseconds, or essentially 1 second. And so when it's set to 1 second, every 1 second, it's this event that will trigger a series of actions. So very specific to the countdown timer. When the countdown timer fires, if you recall, if the score variable was more than 0, it would change by -1, and the counter label would change and it would speak the answer. But that happens every time the timer fires. It's important because you're going to be using it again this week. So you're going to build this game this week. I should probably just show you what the game looks like. So give me a second here. Kind of looks like this. Features your favorite plumber Mario and a mushroom and Bowser, who you got to avoid. And if you press start, then you can use these keys. The goal is to get, oh no, the goal is to get to the mushroom. Bowser's moving pretty quick, so he's hard to avoid. You get down to the mushroom, and you get points for that, and you get bigger, just like in the real game. And when you touch the enemy, you get smaller, and so on. And when you play it all the way through, you'll also have a game over screen. And you guys learned how to add screens in the last week. Okay, so that's what it's going to look like. Let's talk a little more about the specific things that happen. So a major new component. So what you learned about last week was the canvas, and the canvas is useful for animation. And something you can build onto the canvas are sprites. Sprites are sort of very specific programming objects that live only on the canvas, so they won't be floating around the rest of your screen. They won't be getting in your, like the rows that have your control buttons and whatnot. And what's useful about sprites is you can create multiple sprite types. And a sprite type essentially is a category of sprite. So you're going to see what I mean in a second. We're gonna play a little original Super Mario Brothers, and I'll show you what I mean. But so you have the sprite type. It's like the general category of sprites you can add, and the sprites are the little animated characters. A sprite itself is just a single instance of a sprite type. So let me show you what I mean. If you remember in the original Super Mario Brothers for the 8-bit NES, Mario and Luigi, they battle a series of enemies, and we think of them as enemies, and we are probably familiar with the Koopa Troopa and the little Goomba and all those little characters. And what those are sprite types. Like generally, that's the general category of each of these characters. And when you encounter any individual one of these sprite types, it's a sprite. But they're essentially instances. They are examples of the general category. So these are the general category of bad guys, and any individual, villain sprites. And anytime you encounter one of these villain sprites, you're just finding one sprite singular, which is an example of a larger sprite type. So I'm going to show you an example of sprites, sprite types and sprites within an actual game. You may be familiar with the original Super Mario Brothers. We'll watch someone play World 1-1. Oh, we don't need that, and we don't need that. So let's watch what happens here. Okay, so already here's a couple things. Mario there is a sort of a general sprite type, which is the Marios, and this is one Mario in particular. We have here, over here, we have these question blocks, which are a sprite type, even though they can do different things, but they are an instance of a sprite type. Each one of these is the question block sprite. And we also have these bricks, which we know to be another sprite type. Each individual one is a sprite. Let's continue with the game here. All right, we also have the shoots, that's a sprite type. We have the Goomba, that's a sprite type. These are many Goombas, so each one is a sprite. All right, we got this, the question block was a slightly different sprite type because it had the magic flower. Oh, we got the Koopa Troopas. We got another one of these flower sprite types. What else is going on here? We got the bricks, many sprites, individual sprites that are the Goombas. We got the fireballs. Those are also, the fireball is a sprite type. Those are instances of the sprite. And we got the flag. So many different sprite types, and then many different instances of those sprites, just even in Super Mario Brothers World 1-1. Okay, here's some things you'll be building this week. So number one, you'll be using the canvas, which is something you used last week, and you'll be building keyboards. You'll be building buttons to move Mario around. And so some things to remember is, since the origin is 0, 0, to go up, you actually have to decrease the Y value. So that's something you'll have to keep in mind. So for example, even here for the button up click, you'll be taking whatever Mario's current Y value is and actually subtracting 10 if you want to go up. Here's some more things about sprites. They have some interesting properties to consider. You might want to think about how they're draggable, whether they can pass through each other. If the pass through is false, then obviously they can collide with each other and create an event from that. The blocks screen, you can program the sprite's height and width, meaning that you can create procedures for them to grow and for them to shrink. So again, you can make the sprites passable, draggable. You can set on the block screen, you can change the sprite's height and width. Just talk about that. A big event that you'll be using a bunch of times in this is the collides with. So you can set an event to track for whether the different sprites are colliding with each other. Here's what that code might look like. You might set, when they collide, you might send one to a random location on the screen. For example, when the mushroom collides with Mario, or vice versa. So up to now, I think you guys have used the sound component a couple times, and in order to play multiple sounds, what you have done is you've just pulled out multiple sound components. And so what I want you to work on this week is you can actually just use one sound component, and you can play multiple sounds. And the way you do it is under the sound menu, you would grab this thing that says from sound one set source, and it'll be set to all of the media that you put in. In this case, it's a PNG, so it's not going to play, but you can easily find the media that you want. So say you add a sound button, and you can set the source to whatever the media bit is that you want to play, and then call the sound to play. So you're going to do this a couple times because there's a sound for Mario touching the mushroom, Mario getting caught by Bowser, and the end of the game, and so on. So you'll be using this block from sound one set source a bunch of times to change the sound file. To build this, you'll open the template. I've got to start off with 4 rows and a couple labels and a button already set up there for you. I've got, I usually have the video. I think the video is fine. It's just not coming up right here. So I have videos for you. You can also do the step-by-steps, or you can try to build it on your own without anything. That would be pretty pro. That's also not coming up, but that video is there. The 3 challenges you work on is you'll add a timer similar to the countdown timer. So when the timer fires, I guess the variable won't be score, it'll be time, but you'll be checking such things every time the timer fires. You'll also need to initialize a new variable at 20. You'll need to add some code to the when the start button is clicked, and then you'll have to very specifically code out the timer, which is you'll have an algorithm, some pseudocode for you. Second major challenge is you'll need to add a villain sprite. In this case, I'm suggesting you add Bowser. You can add anybody. You can add Justin Bieber, whatever image you want to put in there. Totally fine with me. So you add a new sprite. You're going to create a new procedure. It's called shrink. When the timer fires, you'll add some code to that event to change Bowser's position, and you'll also set some code to watch for when Mario collides with Bowser. A series of things will happen. The very last challenge is the game over screen. So you'll actually add a new screen, and you'll add some code very specifically to the when timer fires, so that if the time is equal to 0, you'll navigate to the game over screen. Those are the challenges. Your task this week, you'll be building Mario's Mushroom Chase. It's the only app. It's the week 7 survey as always, and there's a code.org lesson. It's actually lesson 18. I think I put it was lesson 17 earlier, but you'll be doing lesson 18. I'm going to put a video under the homework because I think it's a little tricky to get started, but I'm sure everyone will be fine. Have a great week. Good luck.